Yeah, students, please listen. So, the next topic is confirmation analysis of n-butane. So, this is also important question for your Unit 3 for your CG2 exam. Okay. So, definitely the question will be there based on the confirmation analysis of n-butane, part B. Okay. So, here you know n-butane means methane, ethane, propane, butane. 4 carbon is there. So, in that 4 carbon, if you are looking at the three-dimensional view as per the Newman-Saber projections, Fisher projection means this is a three-dimensional projection, right? Newman projection. And here the methyl group, methane, the front carbon as a dot, that is 1 carbon, ethane, circle as 1 carbon, propane, and another 1 carbon is there in the opposite side, that is a butane, n-butane. So here, look at the how many possible conformation is there? 6 possible conformations. So just you fix the 1 carbon, backside carbon you fix it, front carbon you rotate 60 degree. Listen here, this is the backside carbon. The circle is a backside carbon. You fix that carbon position. Only the front carbon you rotate 60 degree. 60 degree rotation, front carbon. If you rotate 60 degree means that is a eclipsed structure you get it. So this is here carbon and here methyl group is there. If you rotate 60 degree means it can come and hide it. Okay. So total 120. If you rotate 60 degree means first one staggered means next one eclipsed conformation. Okay. So front carbon only I rotate 60 degree. So you get the second conformation. Third, 4, 5, 6. If you rotate the 6th conformation 60 degree means you get the first one. So here the first conformation is a staggered conformation or is anti-conformation because the methyl group present in the opposite side 180 degree. Okay, here top, here bottom, therefore less steric hindrance. Look at here one methyl group, here one methyl group, there is no steric hindrance. Therefore less energy and more stable. Okay, therefore the first conformation is a more stable conformation. Therefore that is conformation only is available in our nature. Why we have to do the conformation analysis? How many possibilities is there for one compound? How many conformations are there for the one compound? How many conformation is possible for one compound? Out of that, which one is more stable? Which one is available in nature? So here, the less energy is the first conformation only. Therefore, this is a more stable conformation. So if you rotate 160 degree, you get the second conformation. That is a eclipsed structure. Eclipsed structure. That is, you know, the eclipsed structure is a highly unstable one. Because here one methyl group, here another one group means it deviates. There is a more steric hindrance. Think about it, this is a one ball. This is a one ball. How it is stable in the same place? It deviates only. So similarly here, the molecule is not a stable one and high energy is required to stabilize that structure. And if you rotate 60 degree, you get the third conformation. Third conformation is a intermediate stable because the methyl group is close, very close to each other, not for exactly back to back, okay, but 60 degree only is there. So compared to first conformation, here 180, there is no interaction for the fourth carbon and first carbon. But here first and fourth carbon is very close to each other. Therefore, compared to first, the third is a less stable. That is a gauge conformation. Gauge conformation. That is stability is intermediate between staggered and eclipsed. The gauge conformation is an intermediate. And look at here again we rotate 60 degree means the fourth conformation. This is a highly unstable because the methyl group is exactly opposite. Backside is there. So definitely it won't stable. It is not stable in the nature. It is always unstable only. So therefore the fourth one is a highly unstable. Yeah, fourth one is highly unstable. That is eclipsed conformation. And the 2, 4, 6, 2, 4 and 6 is a eclipsed conformation, and the first one is a anti-conformation or a staggered conformation. That's why this is a very less energy. So energy is inversely proportional to the stability. Energy is more, stability is less. Okay, energy is less, stability is more. Okay, so therefore the first conformation is a less energy, more stable conformation, and third and 5 is a intermediate, and 2, 4, 6 is a high energy, therefore that is less stable. Okay, so only to you write it based on the restriction, because of the methyl group is a bulkier group, so both are present in the front and back, means that is due to the restriction it unstable, hence the eclipsed conformation, everything is unstable. Out of 3 eclipsed conformation, the 4th conformation is highly unstable. And staggered conformation, you know that staggered conformation, the first one is an anti-conformation, and that is very highly stable because the methyl group doesn't exactly 180 degree. There is no interaction will be there for the first and 4th carbon, hence that is more stable conformation. Okay, more stable conformation. So you have to draw the diagram, that is mark will be there, and also the potential energy diagram versus this is the angle of rotation. X-axis is the angle of rotation, y-axis is the potential energy. X-axis angle of rotation, y-axis potential energy. And the first one is a anti or staggered conformation, that is highly stable, and 2, 4, 6 is a eclipsed conformation, that is highly unstable. Out of that, the 4th one is more highly unstable, and 3 and 5 is the intermediate conformation. Okay, 3 and 5 is the intermediate conformation. Right. Next we move the. So you have to write it stepwise explanation. That is all 6 conformations, maybe 3, 4 mark is there, and diagram 2 mark, the potential energy versus angle of rotation 2 mark, the rest of the mark for your explanation. Okay, explanation. We have to move very fast because we don't have enough time. Next we move the types of organic reaction and reaction mechanism. Okay, types of organic reaction and reaction mechanism. Yeah. Is there? Types of organic reaction. You know the organic reaction means addition reaction, substitution reaction, elimination reaction, reduction oxidation reaction, rearrangement reaction, naming reaction. Okay, listen. So many types of organic reaction is there. In that, first substitution reaction. Okay, substitution reaction. You write it fully. So you know the substitution reaction means instead of one reactant, we have to substitute some other reactant. That is a substitution reaction. For example, you know the simple CH4 methane, you add HCl. Okay, you add HCl or else chlorine gas. Okay, Cl2 in presence of light, what happened here? CH3Cl. Okay, instead of one hydrogen, Cl substitute. That is a substitution reaction. Okay, substitution reaction. And what is your byproduct mean? HCl. That is well known because which one is a replacement from the reaction that react with one more reactant to given the byproduct. Or else you can take CH3, C, H, and Br. If you add sodium hydroxide, NaOH, what you get it? Sodium and bromine. It remove, you get the CH3, C, H, H, OH plus NaBr. This is also substitution reaction. We have to substitute instead of one group present already, we have to substitute instead of that. That is a substitution reaction. So there you get the ethanol. Okay, ethanol. Ethyl bromide, you can take it, you add the sodium hydroxide, you get the ethanol as a product. So that is a substitution reaction. And next is a addition reaction. Okay, addition reaction. What is the addition reaction? You know CH2, double bond CH2. What is that? What is that? You take a CH3, CH2, Br. This is the addition reaction. Okay, ethylene as a reactant, you add HBr, you get the ethyl bromide. That is a addition reaction. There is no anything removed from your reactant. Whatever we are add A plus B, we get a C product. There is no another byproduct. That is a addition reaction. Okay, addition reaction. Otherwise the same CH3, C double bond O, H plus hydrogen cyanide. What you get it? The Cn minus it's add. Okay. CH3, C, OH. Okay, acetaldehyde cyanohydrate. This is acetaldehyde. You add hydrogen cyanide, you get the acetaldehyde cyanohydrate. That is your product. That is simply add acetaldehyde with HCl. You get the product. There is no removal of any byproduct. That is a addition reaction. Okay, addition reaction. So, what is the difference between here and here? Here, any byproduct it remove from your reactant, then you get the product. Byproduct, that means salt, simple acid, that you remove from the reactant, then you get the byproduct. In addition reaction, not like that. There is no removal of byproduct. Okay, removal of byproduct. And next is a elimination reaction. Elimination reaction is just opposite for your addition reaction. Okay, elimination. Elimination reaction. Elimination reaction means simple. They can take it the same CH2, Br and CH2, Br. What is that? Dibromoethane. 1,2 dibromoethane. So that is your reactant. Just you add a zinc dust. Okay, zinc dust. So that zinc dust remove the bromine. You get the ethylene molecule CH2 double bond CH2 plus ZN-Br2 zinc bromide. Okay, zinc bromide, that is a ethylene. This is a zinc dust, just for powder only. If you add zinc dust in your 1,2 dibromoethane, you get the ethylene molecules. And here also CH2 double bond CH2. If you add bromine gas, you get the CH2 and Br plus Br. 1,2 dibromoethane. You know that is a conformation test for the alkene compound. You add the bromine, the decolorization of that bromine gas. That is a conformation test for your alkene compound. Alkene is present or absent in your compounding. That is a very simple test. That is opposite reaction for your elimination reaction. Okay, elimination reaction. Just opposite. Then rearrangement reaction. Rearrangement reaction means one reactant itself is rearranged and given the different product. That is the rearrangement reaction. Okay. For example, methyl ethyl ketoxide. rearrangement reaction. You take a CH3, C, CH2, CH3, methyl ethyl ketoxane, NOH. Okay. NOH, that is methyl ethyl ketoxane. Methyl ethyl ketoxane. If you rearrangement it's happened in that methyl ethyl ketoxane, what you get the product that N itself, NH, okay, NH, CH3, NH, C double bond O, CH2, CH3, okay, CH2, CH3, that is N-methyl propionamide. So here the oxide into the amide, that is a rearrangement reaction. Here oxide is there, ketoxane. Okay, you know the oxide, what functional group you remember? Alcohol means OH functional group, aldehyde CHO, ketone C double bond O, ester RCOOR, and ether O, and oxide NOH. Okay, NOH. So N-methyl ethyl ketoxane is rearranged itself to get the product of N-methyl propionamide. So here oxide into amide conversion is there. That is a rearrangement reaction. Rearrangement reaction. Right? Here the functional group you remember, because all the functional group is involved in your all organic reaction. So based on that functional group changes only, it is easy for you to predict the mechanism also. So here oxide is there, oxide NOH, C double bond means keto group, C double bond O, that is ketoxane. Okay, ketoxane. Here amide, amide means, what is the amide? Amide functional group. That is amine. NH3, NH2, that is amine. Okay. Ketoxane into amide, CONH. CONH. Okay, CONH. So that is a rearrangement. Rearrange the molecule itself to given the product. So you remember substitution reaction, addition reaction, elimination reaction, rearrangement reaction, reduction and oxidation reaction. Reduction and oxidation reaction means oxidation means oxygen addition, reduction means hydrogen. Okay, hydrogen. So that we will discuss when we take a class. So now we go for the up to addition reaction, your syllabus. What are the types of substitution mechanism is there? So in that free radical substitution and electrophilic substitution reaction, nucleophilic substitution reaction, everything is there. So in that, you know the nucleophilic substitution reaction, SN1 mechanism, SN2 mechanism, everything. I hope you already read that substitution reactions and its mechanism. Okay. Now we go for the free radical substitution reaction. So free radical substitution reaction means first we have to generate the free radical, then initiate that free radical to the propagation step, then termination step. As usual, the polymer reaction, what is happened, the same thing here also. First free radical substitution reaction. May more. Free radical substitution reaction. Okay, free radical substitution reaction. That means we have to know the mechanism for the same CH4 plus Cl2. What we get it? CH3 Cl plus HCl only. Now we go for the mechanism of this methyl chloride preparation. So first we have to generate the free radical, that is initiation step. Initiation. What happened the initiation? This is in presence of light. First free radical generate, that means Cl bond Cl. You know the one bond means two electrons are shared to make a bond, right? And in presence of sunlight or its light, what happens? It will break to give the Cl dot, that is 2 moles of Cl dot you get it. Okay, that is a initiation step. And what is a propagation step? Propagation means it generates the linking. Okay, and propagation. Propagation step, that means CH4 plus Cl dot, this one of the Cl dot, it reacts to form a CH3 dot plus HCl. This is a propagation step, that means radical initiated, that radical to initiate the propagation step. Then the CH3 dot, next step, termination step. Termination step, what happened? That CH3 dot react with one more Cl dot. Okay, one more Cl dot to form CH3 Cl. That is a methyl chloride. This is a free radical mechanism. So free radical means first we have to generate the free radical, then we propagate the first step, then we have to terminate using the one more radicals. That is a termination step. Listen the class, at the same time you make copy the notes. Next is a electrophilic substitution reaction. Okay, electrophilic substitution reaction or else mechanism. This is for free radical mechanism. Free radical mechanism. Now we go for the electrophile. You know the electrophile. Electrophile means what? Positive charge. Yes. Electron lover. Okay. Positive charge. That is a electrophile. H plus. Okay. That is a electrophile. Yes. H plus, Cl plus, Br plus, NO2 plus. That is a electrophile. Nucleophile means negative charge. OH minus, Cl minus, Br minus, I minus, Cl minus. These are all nucleophile. Okay, nucleus level. That is positive charge level. Negative means positive attraction. Positive means negative attraction. That's it. Okay. Now we go to electrophilic substitution reaction. Electrophilic substitution reaction means you take a benzene, you add Br2. You get the bromobenzene, right? Bromobenzene plus HBr. HBr. How the bromobenzene formation is there? That is a electrophilic substitution reaction. So in that we have to add that FeBr3 in presence of brom. This is for just bromination reaction. Okay, bromination reaction. FeBr3. Now, first we have to generate the electrophile. Here free radical means we have to generate the free radical. Electrophilic substitution reaction means we have to generate the electrophile first. Okay. For that, formation of electrophile is the first step. Hence, you take for step 1. What is our step 1? You take a Br2 gas, because the Br2 gas, it reacts with FeBr3. Okay, FeBr3. So to form Br3. Okay, you know the Br means Okay, anyhow, Br bond Br. Okay, Br bond Br, and here FeBr3. So that FeBr3 to react with the Br minus to form Br plus FeBr4 minus. Okay, plus and minus separation. So here which one is the electrophile? Br plus and FeBr4 minus. Which one is electrophile? Br plus is a electrophile. So that electrophile is ready, your substrate is ready. So now you react together, you get the product. So here the first step is a electrophile attack the benzene ring to form a resonance and stabilize the conformation. So for example, step 2. Okay, step 2. What happened? Here the benzene ring is there plus Br plus to form. What happened here? Okay, to form. What happened here? The first step is the here Br, here hydrogen. If addition of Br means here positive charge, right? Because that pi bond only make a bond with your Br. Therefore, hence this carbon is a positive charge. If you want to fulfill that positive charge, pi bond shifting is there. That is your resonance structure. So here Br and hydrogen. Now Br is moving here, means here positive charge. Again this positive charge is there. It move yes.
Both the benzene and Br2 is reactive that we are three different separate curves.
Br2
Because you showed that Br2 first reaction with FeBr3 then again with benzene. So
now first we have to initiate the electrophile, right?
yeah.
For that we have to add FeBr3,
Yeah.
ferric bromide.
No, but like we are also making benzene reactive with it, right? So
I don't understand.
okay, so
Tell me. That is for stepwise we have to explain. This is for what happened when we had Br2 in benzene. So we get the bromobenzene. How the bromobenzene formation we have to explain from step 10. The first step what is happened? We are electrophile.
both of them react
So
separately. Just to show like two different steps.
yes. Now without FeCr3 it won't react. Let us react.
Like you should have steps, right?
Yeah.
So, but actually you have to get together.
Yeah, together. Yes. This is a mechanism. Yeah, student, actually this is a reaction, this is a mechanism. Okay, that is reaction, this is a mechanism. In the mechanism we have to explain how the product is formed stepwise. Okay, that is reaction, what happened overall. Okay, right. So here the positive charge migration continuously. So what happened at the last? Here if it is move the positive charge here, so here positive charge, here hydrogen, here Br. So this positive charge want to neutralize means you remove the H plus from here, this bond is shift to satisfy and you get the product bromobenzene. That's it. Okay, bromobenzene. That is actually the elimination reaction. This is a final step. This is a final step, elimination reaction. Okay, elimination of proton from the benzene ring, then you get the bromobenzene. Right? The next is a nucleophile. Nucleophilic substitution reaction. So nucleophilic substitution reaction. So for example, you take any example for R X react with OH minus. So here this is a nucleophile. So nucleophile it substitute, it remove the X minus, therefore you get the ROH plus X minus. So this is a nucleophilic substitution reaction. The previous one what we do, that is electrophilic substitution reaction. Electrophile we generate and we substitute the electrophile into the substrate, we get the product. Here the nucleophile attack to the substrate to get the product. So here two type of mechanism is there. One is a SN2 mechanism, another one SN1 mechanism. First we explain the SN2 mechanism. SN2 mechanism. Oh, you want to copy? actually two type of mechanism is there, SN1 and SN2 mechanism. That means bimolecular, listen, bimolecular substitution reaction, unimolecular substitution reaction. So what is a bimolecular substitution reaction? So here for example, look at the SN2 mechanism. To take any example, carbon, Br, hydrogen, maybe. Okay, the same. Students, listen. Methyl bromide itself, you take an example. So what happened? The first, the OH minus is there. Okay, OH minus. Yes. OH minus approach to the substrate. There it approach to the substrate means opposite side of the leaving group. Here, what is a leaving group? Which one is ready to leave from the carbon? Alright, which one is leaving from the carbon to form a carbocation? That group is a leaving group. So here, the bromide is a leaving group. OH minus is approach to the back side of that bromide. So what happened? The first step, the carbon, hydrogen, dot, Br. Similarly here also Br. Sorry. OH. So this is a transition state. Transition state. The next step is the product formation. That means here the carbon, hydrogen, OH. This is your product. So here the transition step. Right. This is a SN2 mechanism. So SN2 mechanism is a single step reaction. So here the nucleophile approach to the substrate opposite side of the leaving group. Okay, leaving group, and it form a transition state. What is a transition state? What is the intermediate state? Both are same or both are different, or how it differs? Transition state and intermediate state. Any idea?
Transition is unstable.
Yeah, very good. Transition step is an unstable one. Intermediate step is a stable one. And transition step, you should not isolate that product, but intermediate step, you isolate that intermediate step product. The transition step, then yes, they listen. Don't talk. Okay, and you get the inverse umbrella product. Because there the leaving group is there in the right hand side, and here the nucleophile is there in the left hand side. So exactly inverse umbrella product. That is called Walden inversion. And what is the rate of the reaction? The rate, we know the rate of the reaction, we fix it, which one is a slow step, that is the rate of the reaction. There only we can identify what happened, because it takes more time, then we fix the rate of the reaction. Therefore here, what is the rate of the reaction? The rate of the reaction is depend on both nucleophile as well as substrate. Okay, this is the rate of the reaction. So it depends on nucleophile as well as the substrate. That's why that is a bimolecular substitution reaction. Okay, bimolecular substitution reaction. The rate depends on nucleophile as well as the substrate. Therefore, that is called nucleophilic bimolecular substitution reaction. Okay, substitution reaction. So you have to explain everything. Backside attack, Walden inversion product, transition state, and a transition state. Look at here, 5 bonds are there, but in the initial and the final, carbon have only 4 valency, but here 5 valency. Okay, and here there is no front and back, left and right, everything on the plane. Okay, on the plane, that is a transition state. So backside approach, Walton inversion, rate of the reaction, reaction mechanism, and the inverse umbrella product, everything we have to explain step by step. That is a mark. And next is a SN1 reaction. Okay, SN1 reaction. So here partially leave from the carbon and partially approach towards the carbon. So everything happen in the transition state. Okay, transition. Rate depend upon nucleophile as well as the substrate, both. Next is a SN1 mechanism. SN1 mechanism. What is a SN1 mechanism means? Normally the SN1 mechanism is a two-step reaction. The first step is a carbocation formation. Second step is the nucleophile approach. Okay. First step, step 1. Step 1. SN1 is a unimolecular substitution reaction. Okay. Unimolecular substitution reaction. So first step 1 is a carbocation formation. So for example, look at here. You take any example. CH3, CH3, CH3. If it forms the step 1, this is a carbocation. Okay, carbocation formation is a first step because the first step is a dead slow step because the nucleophile, that is leaving group leave from the carbon to form a carbocation, that is very tough because Br minus itself is a negative charge. Then how you remove from that leaving group from the carbon, that is very tough. Hence the toughest step, that is a slowest step. Which one is a slow step, that is a rate determining step. Therefore carbocation formation is a rate determining step. And second step is a nucleophile approach. Step 2. Step 2 is the nucleophile approach. That means you take a carbocation CH3, CH3, CH3. What happened here? Carbocation is there. If you add OH minus, that is a nucleophile. So two way you get the product. One is a approach towards this direction, or else approach towards this direction also. This direction also. Hence you get the D and L isomer. D and L isomer product. D isomer and L isomer. That is called enantiomers. Okay, enantiomers. So here you get the CH3, 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 OH, otherwise OH. 50%, D and L isomer, 50%. That is a racemic mixture product. You get the 50% of D isomer, 50% of L isomer. Yesterday only we discussed. That is a racemic mixture product. So in the SN1 mechanism, you get the racemic mixture product. So here, what happened? The first step is a rate determining step. So the rate of the reaction, rate is directly proportional to the substrate. That's why that is a SN1 mechanism, unimolecular substitution reaction. The rate is directly proportional to the substrate concentration only, because that is a very slowest step to formation of the carbocation. Okay, carbocation formation. So that is a step 1. So normally the SN1 mechanism follow the tertiary carbons, and SN2 mechanism follow the primary carbons. What are the primary carbons is there? So everything maximum it follow the SN2 mechanism. Tertiary carbon follow the SN1 mechanism. Okay, SN1 mechanism.
Sir, what is the name of the two steps?
First step is a carbocation formation. Carbocation formation. Second step is a nucleophile approach. Nucleophile approach. So you have to explain everything. First step is a carbocation formation. Second step, nucleophile attack to that carbocation. Nucleophile approach to the carbocation. So that secondary alkyl halide, it may undergo hydrolysis either SN1 reaction or its SN2 reaction. Primary and tertiary we classify. Primary follow the SN2 mechanism, tertiary follow the SN1 mechanism. But secondary alkyl halide it follow both SN1, SN2 mechanism based on the reactant and reactant conditions. May move the next one, elimination reaction.
Same content, everyone. Right, पूरी क्लास के पढ़ने के बाद
Yes, student, listen. Next we move the elimination reaction. Yes, student, listen. Elimination reaction. So in that elimination reaction also two type of mechanism is there. E2 mechanism, E1 mechanism. So E2 mechanism, as usual we follow the SN2 mechanism. Here we have to substitute one reactant with other reactant. Substitute. Here eliminate. Okay. So here also the first E2 mechanism. E2 mechanism. How the E1 SN2 mechanism is a single step mechanism. E2 mechanism also single step mechanism. The first step is there. Here the condition is maybe leaving group or else any bromide, iodide, anything. Okay. CH2 maybe OH minus. You can take a substrate. Yeah, listen. So E2 mechanism's condition is the beta carbon must have the hydrogen. Beta proton is compulsory. Okay, beta proton is a compulsory. You know the what is a beta proton? The functional group attached with carbon, that is a alpha carbon. Neighboring carbon is a beta carbon. Neighboring carbon is a beta carbon. Where the functional group or else notified group attached to carbon, that is a alpha carbon. Neighboring carbon is a beta carbon. Therefore, this is the alpha carbon, this is the beta carbon. We have to remove the hydrogen proton from the beta carbon. Then the beta carbon remove the proton means that negative charge migrate towards the leaving group side. Hence, the leaving group leave from the carbon to make a alkene bond. To make a alkene bond. That is a elimination reaction. E2 mechanism. Here, the leaving group leave from the carbon, and the nucleophile remove the proton from the beta carbon. Everything is simultaneously happen. That's why it is the E2 mechanism. So here also the rate of the reaction is depend on both. Okay. Okay, rate of the reaction is depend on nucleophile as well as the substrate. You remember the condition, beta hydrogen is a compulsory. Beta hydrogen is a compulsory. Beta proton is compulsory. So removal of the beta proton from the carbon by the nucleophile, that is compulsory. Okay, right. The next is a E1 mechanism. E1 mechanism is similar for your SN1 mechanism. E1 mechanism. What is the E1 mechanism? Elimination of unimolecular. Okay. The rate of the reaction is here 2. That is a second order reaction. Okay. Order of the reaction is 2. SN2 reaction also. Order of the reaction is 2. Sometimes they ask the MCQ question. What is the order of the reaction for the SN1 mechanism, SN2 mechanism? Okay, you remember that number indicates the order of the reaction. SN2, 2 is the order of the reaction. SN1, 1 is the order of the reaction. And the rate is dependent on the nucleophile as well as the substrate. The second is the SN1 mechanism. Sorry, E1 mechanism. E1 mechanism is similar for your SN1 mechanism. First, the carbocation formation is the first step. You know that is a carbocation formation when the carbon have tertiary.
So the order of the reaction is same for E1, E2 as well.
E1 is order of the reaction is 1. E2 order of the reaction is 2. SN2 and E2 is the same order of the reaction. Similarly, E1 and SN1 is the same order of the reaction. So here bromine, CH3, CH3 and CH3. If you remove the one leaving group from the carbon, you get the carbocation, right? CH3 and CH3, CH3. So the first step is a carbocation formation. There also carbocation formation, right? There also carbocation formation. The rate determining step is the nucleophile. Substrate concentration only, because that is a carbocation formation is a very slow step, hence that is a rate determining step. And second step is a removal of the proton, that is a elimination reaction, right? This is step 1. Step 1. Step 2. What is our step 2 reaction? Proton is abstracted by the base from the adjacent carbon, any carbon. So for example, look at here, CH3, here positive charge is there, here actually CH3 only, but CH2H. If you add OH minus, what happens? It removes the proton from here, it sacrifices that positive charge, therefore what we get it? CH3, C, CH3, double bond CH2. That is your product. Okay, that is your product. 2-methylpropene. That is your product. Okay, 2-methylpropene is your product. So, what is the difference substitution and elimination? Sometimes they ask differentiate between substitution reaction and elimination reaction. Or else, so many questions is possible for substitution and elimination reaction. Difference between SN1, SN2. Difference between E1, E2. Or else difference between SN2, E2, SN1, E1. So many controversial question is possible for substitution and elimination reaction. The same carbocation formation is the first step. nucleophile approach, second step. Or else removal of the proton is the second step. Okay. The addition reaction, mechanism of addition reaction. Okay, now we completed only the mechanism of substitution reaction. Mechanism of substitution reaction. Now we go for the mechanism of addition reaction. Mechanism of addition reaction. There also electrophilic addition reaction, nucleophilic addition reaction. Okay, first, what is a electrophilic addition reaction? Okay, electrophilic addition reaction. So first we have to know about addition reaction means CH2 double bond CH2. When we add HBr, what we get it? Ethyl bromide, CH3 CH2 Br, ethyl bromide. This is the addition reaction. What is the mechanism is there? The first always is a plus and minus separation. Step 1. What happened? HBr to form H plus Br minus. That is the first step, right? H plus Br minus. That is hydrogen bromide gives the proton as well as the bromide ion. Separation of plus and minus. That is the first step. And the second step, step 2, this H plus approach to that alkene group. That means you know the H plus plus CH2 double bond CH2. Both side is a even number of proton is there. So therefore the electron is oscillate. Any one of the side the proton is approached. One side is a positive charge created. Okay, therefore what is the second step? To formation of CH3 CH2 plus, because this electron cloud is moved toward this side, therefore H plus is approached, therefore here del plus and del minus formation is there, hence the del plus approach del minus, this is a del minus and del minus to react H plus to form a CH3 and del plus side completely the positive charge. Okay, completely the positive charge. That means the electrophile attack the pi bond of ethylene to give the carbon ion. Okay, carbonium ion. And the next, actually if you want a carbon, this is a pi bond, right? This is a pi bond. So here only the proton is approach. This is the original mechanism. If you draw the, the carbon p orbital, this is a p orbital, that is a pi bond. Here the proton is approach. Okay, proton is approach. What is the next step? Step 3, the bromide ion attack the carbonium ion to give the addition product. Okay, step 3. Already the carbonium ion formation is there, that is CH3 CH2 plus. Now what happened? that Br minus is there. The Br minus is rested. So Br minus to make a bond to form CH3, CH2, Br. Okay, CH3, CH2, Br. Here the CH2 is a identical proton. Ethylene is a identical proton. Both carbon have number of proton is same. So hence if you add H plus first carbon or second carbon, identical product. In case CH3, CH double bond CH2, that is propene, one propene. There the HBr addition is there, means where the proton is approached to the which carbon, that is a Markovnikov rule. We frame the Markovnikov rule. Based on that, where the proton is approached, the less proton carbon or more proton carbon. The Markovnikov rule says what? You understood, right? Because both the carbon have identical proton, therefore H plus Br minus, wherever it approach, identical product. There is no difference in the product. But in case of the other look at here, step 3. Next, CH3, CH double bond CH2. If you add HBr, what happened? You get the two type of product. One is a proton is approached this side or else that side. So first CH3, CH3. Here Br. This is a one product, and another product CH3, CH2, Br. This is also another product. So which one is a more stable product? One is a n-propyl bromide. Another one is a isopropyl bromide. Isopropyl bromide. Where the proton is approached, less proton carbon or more proton carbon? Less proton carbon. Any idea?
Yes.
Yes, tell me. Which one is more stable product? This is a more stable product. Yeah, listen. Okay. So what is the Markovnikov rule says? The proton approach where the maximum number of proton, that is the Markovnikov rule. Anti-Markovnikov rule says the proton is approached where the less number of hydrogen. When the anti-Markovnikov rule work out, whenever the peroxide is added, there the anti-Markovnikov rule and it's stable the first product. This is a Markovnikov product. Markovnikov rule. The product is more number of proton is there. That carbon only the H plus come and approach. Okay, that is the Markovnikov rule.
So the upper one is empty.
What? So this is a Markovnikov rule product, that is both sides even number of proton and middle bromine is there. Okay, so therefore the H plus is approached here and Br minus is approached here. Therefore the proton is migrate towards this side, pi bond is migrate towards that side. So del plus del minus separation is there, where the del minus, that place H plus approach. Right? So you remember, you know the carbonium ion more stable in the tertiary carbon. Okay, tertiary carbon, which means if the carbon here positive charge means that is a more stable. Tertiary carbonium ion is a more stable than secondary carbonium ion. Okay, secondary carbonium ion is more stable than primary carbonium ion. So you keep remember, because this is also more important rule. Tertiary carbonium ion is a more stable. Means the positive charge created where the more substituent is there, that carbon only positive charge created. Right? May I move the next one?
Sir, 2 p.m.
2 p.m. Yeah, only one copy. It's okay. Addition, yeah. Take copy. And 2 o'clock now, only 15 minutes. I finished the topic. Then we break. Next is a nucleophilic addition reaction. Nucleophilic addition reaction. So for example, you know the any carbonyl group, C double bond O. So here automatically the del plus del minus separation is there, because the carbon and oxygen, carbon is a del plus, carbon O. This is a del minus, this is a del plus, because that is a more electrophilic nature, this is a less electrophilic nature. Okay, del plus del minus. So in case this kind of carbon, suppose you take example CH3, C double bond O. Okay, CH3, C double bond O. What happened? Okay, HCN, addition of the HCN. Okay, keto group addition of the HCN. What happened? You get the product of okay, that is your product. That is acetone cyanohydrin. Acetone cyanohydrin is your product. That is a nucleophilic addition. So we have to go for the stepwise. Similarly for the H plus Cn minus separation. That is the first step. And second step, the Cn minus approach to the carbon. That is the second step. For example, this is a reaction. Now we go for the mechanism. What is the first step? Step 1. Step 1, HCN to form H plus and Cn minus. That is the first step, right? H plus and Cn minus. That is a proton and a cyanide ion. The second step what happened? Step 2, Cn minus approach to the carbon. Okay. Cn minus approach to the carbon. You know the C double bond O, CH3. Here del plus del minus, right? So hence it approach backside attack. What happened here? C CH3. What happened? Cn and O minus. The charge separation is there. Hence O minus and Cn. What is the rest? H plus is there. That H plus come and approach the O minus. That is a step 3. Step 3. CH3, CH3, Cn, O minus plus H plus to form Cn, C, CH3, CH3, OH. Okay, OH, acetone cyanohydrate. So this is a nucleophilic addition mechanism. Nucleophilic addition mechanism. So up to that your syllabus. Not only they didn't ask only the simple reactions, they asked complicated example also. Edema. Acetone cyanohydrate. Last acetone cyanohydrate. That's it today class. Okay, tomorrow we will go for the more examples and discuss in our class. Most of the reactions.